Preamble. In a certain laboratory, the relative uncertainty in length measurements is 0.200%, and the relative uncertainty in density measurements is 0.500%. Find the mass together with its uncertainty of an object with the given properties as determined by the laboratory. So St. Augustine's College, a uniform solid cube whose side is determined to be 8.00 centimeters and whose density is found to be 3.50 times 10 raised to the power 3 kilogram per meter cubed. Yes, upon.
The mass is 1.79 kilograms, and the uncertainty in the mass is 1.100%.
2 out of 3. I'll come back and tell you why.
I know most students are probably thinking this question involves too many formulas, too many calculations, too many decimals, and probably it is impossible to solve this question in a very short time. I agree, this question appears very difficult, but with the hidden tricks and shortcuts that I will show you in this video, you also agree with me that this question only appears to be difficult, but it is very easy to solve it, and you can also do it as well. If you are preparing for the National Science and Maths quiz or WASSCE or NOVDEC, this video is made specifically for you. I'm going to do two things in this video. Number one is that I'm going to take my time and slowly break down the tricks and shortcuts in this video. And number two, I'll show you how all these tricks and shortcuts connect together so that you can solve this question under less than 30 seconds. Let's listen to the preamble.
In a certain laboratory, the relative uncertainty in length measurements is 0.200%.
We are going to use delta for the uncertainty in this question. So as soon as you hear the uncertainty in the length measurement is, then you quickly write it down. So the question went on to say that the
relative uncertainty in density measurements is 0.500%.
So now we have our uncertainty written down. So before we even read the question to you, you know that this question involves density. So you quickly write down the formula for density. Rho will be equal to mass divided by volume. We are going to need it later on in the calculation. So as the question is being read, the trick here is that you quickly write down the formula and you also quickly write down the important information, okay? Because this will save you a lot of time.
Find the mass together with its uncertainty of an object with the given properties as determined by the laboratory.
So now we know what the question wants us to do. So mass will be represented by m plus or minus something. The question mark right there is representing the uncertainty that we will find later on.
A uniform solid cube whose side is determined to be 8.00 centimeters and whose density is found to be 3.50 times 10 raised to the power 3 kilogram per meter cubed.
Notice that the length is given in centimeters, but the density is in meter cubed. So you have to remember that we have to have the same unit. It's either you convert centimeters to meters or you convert meters to centimeters. In this question, for simplicity's sake, I'm going to convert from centimeters to meters. We know that 1 meter is equal to 100 centimeters. So then the length being given in 8.00 centimeters will be equal to 8 times 10 to the power negative 2 meters. Density formula was mass over volume, and we are looking for mass, which is going to be density times volume. We already know density because density was given in the question. We have to find volume. the volume of a cube will be length times breadth times height. In this question, the length, breadth, and height are all the same as 8.00 centimeters. So this means that volume will be equal to length cubed. Then volume, it will be equal to 8 times 10 to the power negative 2 meters, all cubed, okay, because it's L cubed. This will then give us 8 cubed times 10. If you raise a power to a power, you multiply the exponent. So 10 to the power negative 2 raised to the power 3 will be 3 times negative 2, which will give you negative 6. So you have negative 6 m cubed, right? 8 cubed is the same as 8 times 8 times 8, which will give you 512. Okay, so now the volume will be equal to 512 times 10 to the power negative 6 meter cube, which is the same thing as 5.12 times 10 to the power negative 4 meter cube. So we know our density, we know our volume, so we can find the mass, isn't it? Good. So mass, as we know, will be density times volume, will be 3.50 times 10 to the power 3 kilogram per meter cube times volume, which we now have it to be 5.12 times 10 to the power negative 4 meter cubed. Okay. What I'll simply do here is that I want to reduce the numbers so that it will be easier for me to multiply, because if you are multiplying small numbers, it is very easier than multiplying bigger numbers. Okay, so I'll just write 5.12 times 3.50 open bracket 10 exponent 3 times 10 exponent negative 4 kilograms. Remember that meter cubed will cancel meter cubed, so we don't have a problem over that. The unit for mass in this question should be kilograms. Okay, so with this we can further break it down and say 3.50 is simply as saying 3 plus 0.50, because if you do it this way, the numbers become very small for you to multiply. So I will simply write 5.12 open bracket 3 plus 0.50 times 10 power 3 times 10 power negative 4. It will be 10. The exponent will be adding because we are multiplying numbers with the same base. So it will be 3 plus negative 4. 5.12 times 3 will give you 15.36. Then 5.12 times 0.5 is the same thing as saying 5.12 divided by 2 will give you 2.56. If you're able to see this trick or this shortcut, it will save you time from multiplying numbers that have so many decimals. So the mass will be 17.92 times 10 to the power negative 1 kilogram. If we are leaving the mass in 3 sig figs, you will have it to be mass is equal to 1.79 kilograms. Now we have done with the first one, which is finding the mass. We have to now go and look for the uncertainty. So I'm going to give you an illustration that will help you to understand what uncertainty actually means. If you weigh 70 kilograms, depending on the shoe that you are wearing, or even depending on the scale that you are using, your true weight can either be 69.8 kilogram or 70.2 kilograms. Your weight to be written as 70 plus or minus 0.2 kilograms. So all that we are saying here is that your weight, which is 70 kilograms, can be either a little bit higher than 70 kilograms or a little bit smaller than 70 kilograms. That small or that tiny error in the measurement is what we are calling uncertainty. Okay, so now back to the question. The question is asking you to find the tiny errors when you are calculating for the mass. In the preamble, they gave us that the uncertainty in the measurement was 0.200%. So if you take 3 measurements and you make the same tiny errors in that 3 measurements, that means you have 3 times the tiny error, which is the uncertainty. That will give us the total uncertainty in the volume to be equal to 0.600%. To get a total uncertainty percentage, we have to add this value to the uncertainty that we got in the density. So the uncertainty in the density was 0.500%, which will give you 1.100%, which is the same thing as saying 0.011. Now, to find the impact of this uncertainty on the mass, what do you think we should do? We should just simply multiply the mass that we have by this error, which is the uncertainty. So we will have the mass was 1.79 kilograms times 0.011. So over here, we just do it first principle, okay? The number of decimal places here will be 2 decimal places. Over here, we have 3 decimal places. So the total decimal places that we have will be 2 plus 3 will give us 5 decimal places. 179 times 11. And remember, we had 5 decimal places, so we will just count 1, 2, 3, 4, 5. The answer will be 0.01969. If you round it up, you are going to get 0.02. So that will be the uncertainty in the mass calculation. And remember, the errors or the uncertainty is coming from the errors we made when we were measuring the length and the density. Okay. So now the final answer would be 1.79, which is the mass plus or minus 0.02 kilograms. What this simply means to us, if we are scientists, is that science measurements, they are not perfect. So the mass measured in the laboratory, right, can actually be 1.79 plus 0.02, or it can be 1.79 minus 0.02. Just to give you a very quick summary of what we just went through, pay attention to only the important information when the preamble is being read. The number 2 is that remember to convert the unit so that the unit will be the same. The third trick or the third shortcut is to quickly find simple ways of multiplying decimals. And the fourth trick that you have to know is that remember to multiply 3 by the uncertainties that you've been given, because uncertainties or small errors that is made in length measurement is being amplified when we are doing the same measurement 3 times or multiple times. You get it? So now that I've showed you all the tricks, the next stage is that I'm going to show you how all these shortcuts connect together to solve the question under less than 30 seconds.
Next set 30 seconds with a preamble to all schools. Preamble. In a certain laboratory, the relative uncertainty in length measurements is 0.200%. and the relative uncertainty in density measurements is 0.500%. Find the mass together with its uncertainty of an object with the given properties as determined by the laboratory. One more time. In a certain laboratory, the relative uncertainty in length measurements is 0.200%. and the relative uncertainty in density measurements is 0.500%. Find the mass together with its uncertainty of an object with the given properties as determined by the laboratory. All right, so St. Augustine's College, a uniform solid cube whose side is determined to be 8.00 centimeters and whose density is found to be 3.50 times 10 raised to the power 3 kilogram per meter cubed. Yes, upon.
The mass is 1.79 kilograms, and the uncertainty in the mass is 1.100%.
2 out of 3. I'll come back.
If you want more NSMQ tricks and shortcuts, please do check out our NSMQ playlist on Kokochem Education YouTube channel. I always say that practice makes permanent. Keep on practicing, work on your speed, and I promise you, you can do this. And please do subscribe to Kokochem Education YouTube channel. Like, share, comment. Let me know what you think about this video. Until then, see you next time. Bye.
Think, learn,